Hello, friend, and welcome back to Science for Sleep. Tonight, we're turning our attention upward, towards something that has watched over human nights for as long as there have been humans to look back at it. For thousands of years, the moon was not seen as quiet or gentle. It was mysterious, it was powerful, and sometimes it was feared. Ancient stories whispered that the full moon could pull strange thoughts to the surface, loosening the edges of the human mind. Some believed it caused madness, giving rise to the word lunacy, rooted in the Latin word luna. Others told stories of people who transformed beneath its light, or animals who behaved differently when the moon grew bright and round in the sky. In many cultures, the moon was thought to influence birth, sleep, dreams, and even the way emotions move through the body. Midwives watched it closely, farmers planted by it, sailors trusted it, and storytellers warned about it. What's fascinating is not that these myths existed, but that they appeared independently across civilizations that never spoke to one another. From Europe to Asia, from Africa to the Americas, humans sensed that the moon mattered. They felt it long before they understood it. Today, science offers a calmer explanation for that ancient instinct. The moon is Earth's only natural satellite, orbiting our planet at a steady distance of about 384,000 kilometers. Moving with such predictability that we can calculate its position centuries into the future. It does not change its shape. It does not appear suddenly or vanish without warning. Its cycles are slow, rhythmic, and deeply consistent. And yet, despite this reliability, the moon still feels different from everything else in the sky. Unlike stars, it changes its appearance night by night. Unlike the sun, it never overwhelms the darkness. Instead, it softens it. Scientists know that the moon's gravity gently pulls on Earth's oceans, creating tides that rise and fall in a steady rhythm. This connection between moon and Earth is real, measurable, and constant. It's one of the reasons the moon has always felt involved in human life, even when we didn't know exactly why. As we move through this quiet journey together, we'll explore what the moon truly is, how it formed, how it moves, and why it has shaped our planet in ways both obvious and subtle. There's nothing here you need to memorize, nothing you need to hold on to. These are simply gentle facts offered slowly, like moonlight itself. If you enjoy these quiet journeys, I invite you to subscribe, and if you feel comfortable, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. For now, you can let the pace slow even further, allowing your thoughts to loosen. Because the moon does not rush. It does not demand attention. It simply arrives night after night, following a path it has kept for billions of years. And yet, a quiet question still lingers beneath all those ancient stories. Where did the moon come from in the first place? Was it always separate from Earth? Or was it once part of this planet, torn away long ago, before oceans settled and continents took shape? That question, asked in many different ways across history, is one science has been slowly learning to answer. And as we drift onward, we'll begin to explore what researchers believe happened in the earliest days of Earth and Moon alike. I'm glad you're here. It's easy to think of the moon as something familiar rather than something physical, a quiet presence that shares our nights and seems almost personal in the way it follows us across the sky. But beneath that feeling of familiarity is a very real celestial body, shaped by gravity, motion, and immense spans of time. The moon is Earth's only natural satellite, meaning it formed naturally and remains bound to our planet by gravity alone. It does not shine on its own. The light we see at night is sunlight, reflected gently from the moon's surface and softened by distance. In size, the moon is unusually large compared to the planet it orbits. Its diameter is about 1/4 that of Earth, a proportion that makes the Earth-Moon system feel less like a planet with a small companion and more like a paired relationship moving together through space. Because of this size, the moon appears prominent in our sky, often seeming larger than expected when it rises near the horizon, where perspective plays subtle tricks on the human mind. The moon circles Earth at an average distance of about 384,000 kilometers. This distance is close enough for the moon's gravity to reach across space and interact with our planet, yet far enough that the pull feels steady rather than overwhelming. It is this gentle gravitational relationship that allows the moon to influence Earth without disrupting it. One of the most noticeable results of that influence is the movement of Earth's oceans. The moon's gravity draws water toward it, creating slow, rhythmic tides that rise and fall along coastlines around the world. These tides do not rush. They follow a predictable pattern that repeats day after day, mirroring the moon's calm orbital motion. Unlike Earth, the moon has no thick atmosphere to soften its environment. There is no air to scatter light, no wind to shape the surface, and no rain to smooth away markings. As a result, the moon's landscape remains largely unchanged for millions of years at a time, preserving ancient features like craters and lava plains with remarkable clarity. Because there is no atmosphere to hold heat, temperatures on the moon vary dramatically. In sunlight, the surface can become intensely warm, while in darkness it cools rapidly. These extremes exist side by side, separated only by the slow movement of shadow across the lunar ground. The moon also moves with a quiet consistency that has shaped human observation for generations. It rotates on its axis at the same rate that it orbits Earth, a state known as tidal locking. This means the same face of the moon always points toward our planet, giving us a sense of constancy that has lasted as long as humans have been watching the sky. Though the moon's appearance changes through its phases, its presence never truly leaves. It simply shifts its angle, reflecting different portions of sunlight as it moves along its path. What looks like change is really a slow dance of light and perspective, repeating with gentle regularity. This simple understanding of what the moon is creates a foundation for everything that follows. A large, steady companion. A body shaped by gravity and time. A silent partner whose influence is felt even when it is barely visible. And once we understand what the moon is today, we can begin to explore the deeper question that naturally follows: how something so closely connected to Earth came to exist at all, and what that origin reveals about the earliest history of both worlds. For as long as humans have looked up at the moon, they have wondered whether it had always been there, quietly accompanying Earth through time, or whether it arrived later, shaped by some distant event in the planet's earliest days? That question lingered for centuries, carried forward by myth and curiosity alike, until science began offering gentle ways to explore it. Early ideas about the moon's origin were simple and intuitive. Some suggested it formed elsewhere in the solar system and was later captured by Earth's gravity. Others imagined that Earth and Moon formed side by side from the same cloud of material, growing together as neighbors. And for a long time, there was also the thought that the Moon might once have been part of Earth itself, slowly separating long ago. As scientists gathered more evidence, many of these early ideas became harder to support. The Moon's orbit is unusually circular and stable, which makes a random capture less likely. Its internal structure and density differ from Earth's in subtle but important ways, suggesting a more complex origin than simple co-formation. Today, the leading explanation is known as the giant impact hypothesis. This idea suggests that very early in Earth's history, when the solar system was still young and unsettled, a Mars-sized body passed close enough to Earth for gravity to draw the two worlds into a brief, transformative encounter. Rather than imagining this as a sudden collision, scientists describe it as a slow, energetic merging of material, unfolding over hours rather than moments. Rock from Earth's outer layers and material from this passing body were lofted into orbit, forming a vast ring of debris around the planet. Over time, that debris began to come together. Small fragments collided gently, stuck, and grew. Gravity did the slow work of gathering scattered material into a single body, gradually forming what would become the Moon. One of the strongest pieces of evidence for this idea comes from the composition of lunar rocks. Samples brought back by Apollo missions show that the Moon's material closely resembles Earth's outer layers, especially its mantle. At the same time, the Moon contains far less iron than Earth, suggesting it did not form from Earth's dense core, but rather from lighter surface material. Computer simulations also support this scenario. When scientists model early Earth with a large nearby body passing close enough to exchange material, the resulting debris patterns closely match the Moon's current mass, 1.5% of Earth's mass, orbit, and composition. While no single model captures every detail perfectly, many arrive at similar outcomes, reinforcing the idea that the Moon emerged from Earth's earliest environment. What makes this origin especially fascinating is how quickly calm followed chaos. After forming, the Moon began settling into its orbit, while Earth cooled, oceans condensed, and the planet slowly became more stable. In time, the Moon's gravity helped steady Earth's rotation and tilt, contributing to the long-term balance that made life possible. So in a very real sense, the Moon may carry pieces of Earth within it, not as a fragment torn away in violence, but as material gently reshaped and reorganized by gravity and time. A shared history written into stone, drifting quietly overhead. As we continue, we'll look more closely at how the Moon's surface reflects this ancient origin, preserving records of events that Earth itself no longer remembers. Because the Moon, unchanged by wind or water, has been keeping a remarkably patient archive of the solar system's earliest days. When we look at the Moon from Earth, its surface appears patterned and familiar, marked by bright highlands and darker patches that seem almost painted onto the sky. These features are not shadows or stains. They are records, preserved with unusual clarity, telling a story that stretches back billions of years. The moon's surface is divided into two broad regions that can be seen even without a telescope. The lighter areas are known as highlands, made mostly of older, thicker crust that formed early in the moon's history. These regions are heavily cratered, layered with the marks of countless impacts that occurred when the young solar system was still crowded with drifting material. The darker regions are called Maria, a term that means seas, given by early observers who believed these smooth areas were filled with water. In reality, the Maria are vast plains of solidified lava. Long ago, molten rock welled up from beneath the moon's surface and spread outward, cooling slowly and creating these broad, dark expanses. This volcanic activity did not involve flowing rivers or erupting mountains as we might imagine on Earth. Because the moon has lower gravity and no atmosphere, lunar lava behaved differently, spreading thinly across large areas before settling into stillness. Once cooled, these lava plains remained largely unchanged, forming some of the smoothest regions on the moon. Covering nearly all of the lunar surface is a fine, powdery layer called regolith. This material is made of crushed rock and dust, created over immense spans of time as tiny impacts repeatedly broke down the surface. Without wind or water to move it, regolith simply accumulated, slowly deepening as more material arrived. The craters scattered across the moon vary widely in size and shape. Some are small and sharp-edged, formed by relatively recent impacts. Others are broad and softened, their rims worn down by countless smaller collisions over time. By studying these craters, scientists can estimate the relative ages of different regions, reading the surface like a quiet clock. Unlike Earth, the moon has no active plate tectonics to recycle its crust. There are no shifting continents or erasing forces at work. Once a feature forms on the moon, it tends to remain, fading only slightly as more dust settles and more tiny impacts occur. This lack of change is what makes the moon such a valuable record keeper. While Earth's surface has been reshaped repeatedly by oceans, erosion, and geological motion, the moon preserves scenes from an earlier era of the solar system that Earth itself has forgotten. Even the smallest details tell part of this story. Glass beads formed by ancient impacts are scattered within the soil. Subtle differences in rock chemistry reveal where lava once rose from below. Each quiet detail adds another layer to our understanding of how the moon and the solar system around it slowly took shape. As we drift onward, we'll begin to explore why this surface has remained so unchanged for so long, and how the absence of air and weather has allowed the moon to hold on to its history with such remarkable patience. One of the reasons the moon's surface has remained so still and unchanged is that it exists in an environment very different from Earth's. There is no breeze moving across its plains, no clouds forming and dissolving overhead, no rain falling to soften edges or carry dust from one place to another. The moon has no substantial atmosphere. Its gravity is too weak to hold on to thick layers of gas for long periods of time, and over billions of years, most of what once surrounded it drifted away into space. What remains today is an extremely thin exosphere, so faint that it behaves less like air and more like scattered individual particles. Because of this, the moon has no weather in the way we experience it on Earth. There are no winds to shape the landscape, no storms to rearrange the surface, and no seasons marked by shifting air patterns. When sunlight strikes the moon, it does so directly, without being filtered or scattered by clouds or atmosphere. This absence of air has a noticeable effect on temperature. During the long lunar day, which lasts about 2 Earth weeks, the surface can grow very warm under continuous sunlight. When night arrives, temperatures fall just as steadily, dropping to extreme cold as heat escapes back into space. These changes happen slowly, following the moon's unhurried rotation. Without air to carry sound, the moon is also profoundly silent. Any vibration created on its surface fades quickly, unable to travel as it would through Earth's atmosphere. This quiet is not an absence, but a natural consequence of a world shaped almost entirely by gravity and vacuum. The lack of weather also means that marks on the moon last for astonishing lengths of time. Footprints left by astronauts remain exactly where they were made, untouched by wind or rain. Tracks from equipment and tools stay sharp-edged, preserved as clearly today as the moment they were pressed into the soil. Even small impacts behave differently in this environment. When a tiny meteor strikes the moon, there is no air to slow it down. The energy of the impact is transferred directly into the surface, creating craters that spread outward in delicate radial patterns. These patterns remain visible for millions of years, slowly softened only by the gentle rain of even smaller particles. This stillness gives the moon a timeless quality. Events that happened long before Earth's continents settled into their current shapes remain visible, quietly resting under the same sky we see today. The moon does not erase its past. It simply layers new moments gently on top of old ones. As we continue drifting forward, this lack of weather will help explain why the moon feels so steady and predictable, and why its movements through the sky have always offered a sense of rhythm rather than surprise. In the next stretch of our journey, we'll begin to look at how the moon moves and why its motion feels so calm and reliable night after night. The moon's movement around Earth is so steady that it can be easy to forget it is always in motion. Night after night, it rises and sets, tracing a familiar path across the sky, following a rhythm that rarely surprises. This sense of calm comes from the nature of its orbit, shaped by gravity and refined over immense stretches of time. The moon travels around Earth in a wide, slightly oval path known as an orbit. On average, it completes one full journey around the planet in a little over 27 days. This motion is not hurried. It is smooth, continuous, and guided by the quiet balance between the moon's forward momentum and Earth's gravitational pull. Because the orbit is not a perfect circle, the moon's distance from Earth changes slightly over the course of each cycle. Sometimes it drifts a little closer, appearing subtly larger in the sky. At other times, it moves farther away, looking slightly smaller and dimmer. These changes are gentle and gradual, unfolding over days rather than moments. As the moon orbits Earth, it also turns slowly on its own axis. What's remarkable is that these two motions are synchronized. The time it takes the moon to rotate once is the same amount of time it takes to complete one orbit around Earth. This synchronization is what creates tidal locking, ensuring that the same side of the moon always faces our planet. Tidal locking did not happen instantly. Early in the moon's history, its rotation was likely faster and less regular. Over time, Earth's gravity created subtle internal friction within the moon, gradually slowing its spin until the two motions settled into balance. Once achieved, this state remained stable, reinforcing the moon's sense of permanence in our sky. From Earth's surface, this consistency makes the moon feel familiar. Certain craters and dark plains appear in the same positions every time we look up. Generations separated by thousands of years have seen the same lunar face, framed by different cultures, stories, and nights. The moon's orbit also tilts slightly relative to Earth's path around the sun. This tilt is small but important, influencing when eclipses can occur and why they are relatively rare. Most of the time, the moon passes above or below the line between Earth and the sun, continuing its journey without interruption. All of this motion happens quietly, without effort or sound. The moon does not wobble unpredictably or wander off course. It follows a path shaped long ago, one that has proven remarkably stable over billions of years. As we drift onward, this gentle orbital dance will help us understand the moon's changing appearance in the sky. Because while the moon itself remains the same, the way we see it depends entirely on where it is. Along this calm, repeating path, the moon often appears to change shape as the days pass, growing thin and bright, then round and full, before slowly fading again. For much of human history, this shifting appearance felt mysterious, as if the moon itself were transforming. In reality, the moon remains the same solid sphere throughout these cycles, and what changes is simply the way light reaches our eyes. The phases of the moon are caused by its position relative to Earth and the sun. As the moon travels along its orbit, different portions of its sunlit side become visible from Earth. When the moon sits between Earth and the sun, the side facing us receives little direct light, creating what we call a new moon. At this point, the moon is still present in the sky, but its brightness blends quietly into the daylight. As the moon continues moving, a thin curve of reflected sunlight begins to appear along its edge. This is the crescent phase, where only a small portion of the moon's illuminated surface is visible. Each night, that illuminated area grows, not because the moon is changing, but because our viewing angle is slowly shifting. When half of the moon's face appears bright and the other half dark, it is known as a quarter moon. Despite the name, this phase shows half of the moon's visible surface illuminated. The term comes from the moon having completed roughly 1/4 of its orbit since the new moon. As the cycle continues, more of the illuminated surface becomes visible, leading to the gibbous phase. During this time, the moon appears almost full, glowing softly for much of the night. The gradual nature of this change is what gives the lunar cycle its calming rhythm, unfolding over days rather than moments. The full moon occurs when Earth lies between the sun and the moon, allowing sunlight to fully illuminate the face we see. At this point, the moon rises as the sun sets and remains visible throughout the night. Its brightness is steady rather than harsh, reflecting sunlight that has already traveled across space and been softened by distance. After the full moon, the visible light begins to recede. The moon enters another gibbous phase, this time shrinking night by night. Eventually, it returns to a quarter phase, and then to a waning crescent, as less of the illuminated surface remains in view. This entire cycle takes about 29.5 days to complete, slightly longer than the Moon's orbital period. The difference comes from Earth's own movement around the Sun, which shifts the alignment needed for the same phase to appear again. This subtle interplay between motions creates the steady pace of the lunar month. What's important to remember is that nothing is happening to the Moon itself during these phases. No part of it is disappearing or being covered. The changes exist only in perspective, shaped by geometry and light, rather than transformation. For the human mind, these repeating phases have long served as a natural clock. They offer a sense of progression without urgency, marking time in a way that feels organic rather than imposed. Even today, many people find comfort in noticing the Moon's phase, feeling grounded by its familiar return to the same shapes again and again. As we continue drifting forward, this understanding of the Moon's phases will help us explore moments when the usual pattern briefly aligns in special ways. Because under certain conditions, the positions of Earth, Moon, and Sun create rare and beautiful events that gently interrupt this steady cycle. Every so often, the steady rhythm of the Moon's motion creates a moment that feels different. Not because anything moves faster or louder, but because everything lines up just right. These moments are eclipses, and they happen only when the geometry of Earth, Moon, and Sun briefly aligns in a very specific way. Most of the time, the Moon passes slightly above or below the direct line between Earth and the Sun. Its orbit is tilted just enough that these bodies usually miss one another in perfect alignment. Because of this gentle tilt, eclipses are uncommon, appearing only a few times each year rather than every month. A solar eclipse occurs when the Moon moves between Earth and the Sun. From certain places on Earth, the Moon appears to cover the Sun's bright face, turning daylight briefly dim and cool. This happens because the Moon and the Sun appear almost the same size in the sky, even though the Sun is vastly larger and much farther away. This matching appearance is a coincidence of distance and scale. The Sun is about 400 times wider than the Moon, but it is also about 400 times farther from Earth. As a result, the Moon can fit neatly over the Sun from our point of view, creating a temporary overlap of light and shadow. A lunar eclipse unfolds more quietly. It happens when Earth moves between the Sun and the Moon, allowing Earth's shadow to fall across the lunar surface. As the Moon passes through this shadow, it does not disappear. Instead, it often takes on a soft copper or red hue, caused by sunlight bending through Earth's atmosphere and reaching the Moon indirectly. This filtered light carries the colors of Earth's skies. Blues scatter away, while reds and oranges curve gently around the planet, illuminating the Moon in muted tones. In this way, a lunar eclipse becomes a subtle collaboration between Earth and Moon, linked by light rather than blocked by darkness. Eclipses do not last long. They unfold over hours, then pass, returning the sky to its familiar patterns. There is no disruption to the Moon's orbit or Earth's motion. Once alignment shifts, everything resumes its steady course, as if nothing unusual occurred. For much of human history, eclipses were surrounded by fear and meaning. They were seen as omens or messages, interruptions in what was otherwise predictable. Today, Science understands them as natural outcomes of motion and alignment, governed by the same calm rules that guide every orbit. What makes eclipses feel special is not danger or drama, but rarity. They remind us that even within steady systems, brief moments of symmetry can appear. Moments when shadow and light overlap perfectly, then drift apart again. As we continue drifting onward, this understanding of alignment will help explain how the moon influences Earth in quieter, more constant ways. Not through rare events, but through forces that act slowly and persistently, shaping rhythms that repeat long after eclipses have faded back into memory. Long before the moon was understood as a physical body moving through space, people noticed its quiet relationship with the sea. Shorelines would change their shape throughout the day. Water would advance, then retreat, following a rhythm that felt older than memory. Over time, it became clear that these movements were not random, but carefully timed with the moon's presence in the sky. The tides are created by gravity. Every object with mass exerts a gravitational pull, and the moon, though much smaller than Earth, is close enough for its gravity to reach us in a noticeable way. This pull acts most strongly on the oceans because water can move freely in response to gentle forces. As the moon orbits Earth, its gravity draws ocean water slightly toward it, creating a bulge on the side of the planet facing the moon. At the same time, a second bulge forms on the opposite side of Earth, caused by the balance between gravitational pull and Earth's own motion. As Earth rotates, coastlines pass through these bulges, creating the familiar rise and fall of the tides. This process is slow and continuous. There is no sudden surge or dramatic shift. Tides change gradually, often taking hours to reach their highest or lowest point. This steady pace is part of what has made tides feel calming rather than threatening, especially when observed over long stretches of time. The sun also plays a role in Earth's tides. Although it is far more massive than the moon, its greater distance means its tidal influence is less pronounced. When the sun and moon align during new and full moons, their gravitational effects combine, producing slightly higher high tides and lower low tides, known as spring tides. When they sit at right angles to each other, tides become more moderate, creating what are called neap tides. These variations follow a predictable pattern, repeating month after month. They are not signs of imbalance, but expressions of harmony between moving bodies. The oceans respond to these forces the way a calm surface responds to a gentle hand, shifting without resistance. Over very long periods of time, the interaction between Earth's tides and the moon's gravity has had lasting effects. As tidal energy is transferred, Earth's rotation slows ever so slightly, and the moon drifts gradually farther away. This change is extremely small, measured in centimeters per year, but it has been happening steadily for billions of years. This slow exchange of energy has helped stabilize Earth's rotation, preventing large, sudden changes in the length of a day. In this way, the moon has acted as a quiet regulator, contributing to the long-term consistency of Earth's cycles. Even life on Earth has adapted to these rhythms. Many coastal organisms time feeding, movement, and reproduction with the tides. These patterns are guided not by conscious awareness of the moon, but by the dependable rise and fall of water shaped by its gravity. For the human mind, Tides offer a visible reminder of connection. They show that the moon's influence is not distant or abstract, but present and ongoing, touching the edges of continents and shaping the boundaries between land and sea. As we continue drifting forward, we'll begin to explore how this gravitational relationship extends beyond water alone, and why the moon's influence has often been felt in subtle, sometimes misunderstood ways within human experience itself. For centuries, people have wondered whether the moon's presence reaches beyond oceans and shorelines, quietly influencing human behavior as well. Stories passed down through generations suggest changes in mood, restlessness during full moons, and nights that feel different when lunar light fills the sky. These ideas became so familiar that they shaped language itself, linking the moon to the inner workings of the human mind. The word lunacy comes from the Latin luna, reflecting an old belief that mental states could shift with the moon's cycle. In earlier times, hospitals and caretakers often expected nights around the full moon to be more unsettled. These expectations were shaped by observation, storytelling, and a natural tendency to notice patterns, especially during unusual or memorable events. Modern science has approached these ideas with careful study. Researchers have examined hospital records, crime reports, sleep data, and mood surveys to look for consistent links between lunar phases and human behavior. Across many large studies, most results show little to no direct effect of the moon on aggression, decision-making, or emotional instability. When it comes to sleep, the picture becomes slightly more nuanced. Some studies suggest that around the time of a full moon, people may experience subtle changes in sleep duration or depth. These effects, when present, are small and inconsistent, often influenced by environmental factors such as light exposure rather than gravity itself. Moonlight is significantly dimmer than sunlight, but before artificial lighting became widespread, it could still brighten the night enough to alter human routines. In earlier societies, a bright moon meant extended activity after sunset, later bedtimes, and more social interaction. These behavioral changes may have shaped the long-standing belief that the moon directly altered the mind, when in fact, it was changing the environment around it. Expectation also plays an important role. When people believe a certain night will feel different, they are more likely to notice disruptions or emotional shifts. This doesn't mean the experience isn't real, but rather that perception and belief can gently shape how events are remembered and interpreted. The moon's gravitational influence on the human body is extremely small. While it moves vast amounts of ocean water, the force it exerts on an individual person is far weaker than the gravitational effects of nearby objects in everyday life. From a scientific perspective, gravity alone is unlikely to directly alter thoughts, emotions, or behavior. And yet, the moon continues to feel meaningful. It marks time. It changes the look of the night sky. It signals transition, rhythm, and return. These qualities naturally resonate with the human mind, which is deeply attuned to cycles and patterns. Rather than causing behavior, the moon may serve as a quiet mirror. It reflects our awareness of change, reminding us that nights differ from one another, even when the world itself remains calm and steady. In this way, the moon influences experience not through force, but through presence. As we drift onward, we'll continue exploring how the moon has shaped human understanding, not just through physical effects, but through the way it has guided timekeeping, culture, and the slow rhythms of life itself. Long before clocks, calendars, or written schedules, humans learned to sense time by watching patterns in the natural world. Among all the movements in the sky, the moon offered the clearest and most approachable rhythm. It changed slowly enough to be followed with the eye, yet consistently enough to be trusted, night after night. A complete cycle of lunar phases takes just over 29 days. This repeating pattern became one of the earliest foundations for measuring time, giving rise to the concept of a month. Even today, the structure of modern calendars still carries echoes of this lunar influence, despite later adjustments made to align months with the solar year. Early societies did not experience time as something counted in minutes or hours. Instead, time was observed. The appearance of a crescent moon marked a beginning. A full moon signaled completion or abundance. The gradual transition between these phases offered a visible reminder that change was unfolding, even when daily life felt unchanged. Many ancient civilizations built entire systems of timekeeping around this cycle. Lunar calendars were used in Mesopotamia, ancient China, and across parts of the Americas, each shaped by careful observation rather than calculation. Because 12 lunar cycles do not align perfectly with one solar year, these calendars required occasional adjustments, creating systems that were flexible rather than fixed. This flexibility reflected an acceptance of natural drift. Instead of forcing time into rigid segments, lunar calendars allowed small differences to accumulate, then gently corrected them over longer spans. In this way, time was treated as something that flowed, not something that needed constant precision. The moon's visibility made it especially powerful as a shared reference point. Entire communities could look up and see the same phase at the same moment, without instruments or training. This shared observation synchronized human activity, helping groups coordinate gatherings, ceremonies, and seasonal work. Religious and cultural traditions often grew around these rhythms. Festivals were timed to full moons. Periods of rest or reflection followed predictable lunar points. Even today, several major observances, including Ramadan and Passover, continue to follow lunar or lunisolar calendars, shifting slightly each year as moon cycles interact with Earth's orbit around the Sun. From a scientific standpoint, the moon's usefulness as a timekeeper comes from the stability of its orbit. Its motion is predictable across long spans of time, allowing its phases to repeat with remarkable consistency. This reliability made the moon one of the first natural clocks available to human observation. For the human mind, lunar time feels fundamentally different from mechanical time. It does not demand attention. It does not announce itself. It reveals itself gradually, encouraging awareness rather than urgency. You don't need to count anything to notice a full moon rising. You simply recognize it, the way you recognize a familiar face. This kind of timekeeping invites patience, reminding the mind that not all change needs to be measured to be meaningful. As we continue drifting forward, this relationship between the moon and time will help us understand why lunar cycles feel grounding rather than stressful. Because the moon does not rush time forward, it allows it to unfold gently, returning again and again to the same familiar shapes. while everything else slowly changes around it. For most of human history, the moon presented a single, familiar face. Night after night, the same patterns appeared, the same dark plains and bright highlands arranged in a way that felt almost intentional. It was natural to assume that the rest of the moon looked much the same, hidden but unchanged, simply turned away from view. This assumption existed because of the moon's tidal locking. As the moon orbits Earth, it rotates at the same rate, keeping one hemisphere always facing our planet. The opposite hemisphere, often called the far side, remained unseen from Earth for thousands of years, not because it was hidden in darkness, but because its orientation never shifted toward us. It's important to clarify that the far side of the moon is not permanently dark. It receives just as much sunlight as the near side over the course of a lunar cycle. When the near side experiences night, the far side is bathed in sunlight. And when the far side enters darkness, the familiar face we see is illuminated instead. The difference lies in visibility, not light. The first direct observations of the far side came in the mid-20th century, when spacecraft were finally able to travel beyond Earth's immediate surroundings. In 1959, the Soviet probe Luna 3 transmitted the first images of the moon's far side back to Earth. These early photographs were grainy and incomplete, but they revealed something unexpected. The far side of the moon looks noticeably different from the side we know so well. It has far fewer maria, those broad, dark lava plains that dominate much of the near side. Instead, the far side is covered mostly in rugged highlands, densely packed with craters and marked by thicker crust. Scientists believe this difference is tied to the moon's internal structure and early cooling process. The near side's crust is thinner, which allowed molten rock to rise more easily and flood large areas long ago. On the far side, the crust is thicker, making it more difficult for lava to reach the surface and spread. This imbalance may have been influenced by Earth itself. Early in the moon's history, the side facing Earth was kept warmer for longer periods due to Earth's heat and gravitational effects. That additional warmth may have contributed to uneven cooling, subtly shaping the moon's two hemispheres in different ways. Modern missions have mapped the far side in remarkable detail. Orbiters equipped with cameras, spectrometers, and gravitational sensors have revealed massive impact basins, complex layering beneath the surface, and chemical differences that add depth to our understanding of lunar history. One of the largest features, the South Pole Aitken Basin, stretches thousands of kilometers and offers insight into impacts that occurred very early in the solar system's formation. For scientists, the far side of the moon is especially valuable for another reason. It is naturally shielded from radio interference caused by Earth's technology. This makes it one of the quietest places in the inner solar system for certain types of astronomical observation, where faint signals from deep space can be studied without disturbance. For the human mind, the far side of the moon represents something more subtle. It reminds us that familiarity does not equal completeness. Even something we have watched our entire lives can still hold unseen depth, waiting patiently beyond our usual point of view. As we drift onward, this expanded understanding of the moon prepares us to look more closely at its interior. Because beneath both faces, familiar and unseen, the moon carries internal structures and slow processes that continue to shape it in quiet, measurable ways. When we think about the moon, it's natural to imagine only what we can see from the outside. A pale surface, dark plains, quiet craters resting under sunlight and shadow. But like Earth, the moon has an interior, shaped by heat, pressure, and slow changes that unfolded long before humans ever looked up at the sky. For a long time, scientists could only guess what lay beneath the moon's surface. There were no deep drills or direct samples from its interior. Instead, understanding came gradually, through careful observation, mathematics, and the study of subtle signals traveling through lunar rock. One of the most important tools for exploring the moon's interior came from seismic instruments left behind by astronauts during the Apollo missions. These devices detected moonquakes, gentle vibrations caused by internal stresses, meteor impacts, and tidal forces from Earth. By studying how these vibrations traveled through the moon, scientists could infer what kinds of layers lay beneath the surface. The moon is composed of several main internal regions. At the center lies a small core, made mostly of iron, with traces of other elements. This core is much smaller relative to the moon's size than Earth's core is to our planet, which helps explain why the moon lacks a strong magnetic field today. Surrounding the core is the mantle, a thick layer of rocky material that once held enough heat to allow molten rock to move. Early in the moon's history, this heat powered volcanic activity, sending lava up through fractures in the crust and creating the dark maria visible from Earth. Over time, as the moon cooled, this activity slowed and eventually came to a near standstill. Above the mantle lies the crust, the outer shell we see today. This crust varies in thickness, being thinner on the side facing Earth and thicker on the far side. These differences played an important role in shaping the moon's surface, influencing where lava could emerge and where it remained trapped below. Although the moon is often described as geologically inactive, it is not completely still. Moonquakes continue to occur, though they are generally weaker and longer lasting than earthquakes. Some are caused by temperature changes as the lunar surface heats and cools. Others result from tidal forces as Earth's gravity gently flexes the moon's interior. These subtle movements remind us that the moon is not a frozen object, but a body that still responds to forces acting upon it. Change happens slowly here, measured in millimeters and micro movements rather than dramatic shifts. The moon's interior also holds clues about its earliest moments. Its relatively small core and specific rock composition support the idea that it formed from material ejected during a massive early encounter, rather than growing independently like a small planet. In this way, the moon's interior quietly confirms the story told by its surface. For the human mind, it can be comforting to remember that even something that appears perfectly still carries hidden motion within it. Not everything that matters is visible. Some processes work silently, shaping outcomes over long stretches of time without ever drawing attention to themselves. As we continue drifting forward, this understanding of the moon's inner structure will help us appreciate how the moon once held heat and energy, and how its gradual cooling shaped the calm, steady companion we see today. Today, the moon appears calm and exposed, lacking many of the invisible forces that quietly shape Earth's environment. There is no strong magnetic field surrounding it, no protective bubble guiding charged particles away from its surface. Space reaches the moon directly, uninterrupted. But this has not always been the case. Long ago, the moon possessed a magnetic field of its own, one that existed during its earliest and most active period. This ancient magnetism has long since faded, but traces of it remain preserved within lunar rock, offering quiet clues about the moon's interior history. Evidence for this early magnetic field comes primarily from lunar samples collected during the Apollo missions. Some of these rocks contain minerals that recorded the presence of magnetism as they cooled. Much like tiny compasses frozen in stone, these minerals aligned themselves with the moon's magnetic field billions of years ago, preserving its direction and strength. By studying these samples, scientists discovered that the moon's magnetic field may once have been surprisingly strong. In some periods, it appears to have reached strengths comparable to Earth's present-day magnetic field. This was unexpected for a body as small as the moon, and suggested that its interior was once far more dynamic than it appears today. Magnetic fields typically arise from the movement of molten, electrically conductive material within a planet's core. On Earth, this motion continues because the core remains hot and layered, allowing heat to drive circulation. On the Moon, however, the situation was different. Its smaller size meant that internal heat escaped more quickly, limiting how long such motion could be sustained. For a time, the Moon's core may have remained partially molten, allowing internal movement to generate magnetism. Some models suggest that the Moon's early magnetic field may also have been supported by mechanical stirring caused by tidal interactions with Earth. As the young Moon orbited closer to our planet, gravitational forces may have helped maintain internal motion, extending the life of its magnetic field. Over hundreds of millions of years, this internal energy slowly diminished. As the Moon cooled, its core became less active, and the processes required to generate a global magnetic field weakened. Rather than ending abruptly, the magnetic field faded gradually, declining in strength until it could no longer sustain itself. Although the Moon no longer has a global magnetic field today, localized remnants still exist. Certain regions of the lunar crust retain weak magnetic signatures, locked into rock long ago. These areas can subtly deflect charged particles from the Sun, creating swirling patterns on the surface known as magnetic anomalies. These faint magnetic patches are especially noticeable where solar particles interact with the Moon's surface. In some places, they appear to protect small areas from space weathering, leaving behind lighter-colored patterns that contrast with darker surroundings. These features act as delicate fingerprints of a force that once shaped the Moon more broadly. The loss of the Moon's magnetic field had long-term consequences. Without a protective magnetic shield, the lunar surface became fully exposed to solar wind and cosmic radiation. Over time, this exposure contributed to the gradual alteration of surface materials, darkening rocks and breaking down minerals at the atomic level. For the human mind, this story carries a quiet resonance. The Moon was once more active, more internally energized, and more protected than it is now. Its current stillness is not a flaw, but the result of completion. A world that has finished changing and settled into balance. As we continue drifting forward, this understanding of the Moon's magnetic past will help explain how sunlight and space continue to shape its surface today. Because even in stillness, the moon remains in constant conversation with the forces flowing outward from the sun. Although the moon appears quiet and distant, it is constantly interacting with the sun in subtle and continuous ways. Without a thick atmosphere or a strong magnetic field, the moon experiences sunlight directly, allowing space itself to reach its surface without much resistance. This interaction is gentle, persistent, and central to understanding how the moon slowly changes over time. The sun releases a steady stream of charged particles known as the solar wind. These particles flow outward through the solar system, carrying energy and magnetic influence with them. On Earth, most of this solar wind is guided around the planet by our magnetic field and filtered by the atmosphere. On the moon, there is no such shield. As a result, solar wind particles strike the lunar surface directly. When they collide with the moon's soil, they interact with atoms in the rock, subtly altering their structure. Over long periods, this process contributes to space weathering, a gradual transformation that darkens the surface and changes how it reflects light. One of the most interesting outcomes of this interaction is the creation of tiny amounts of hydrogen within the lunar soil. Some of this hydrogen comes from the solar wind itself, embedding into surface materials as particles impact the ground. In colder, permanently shadowed regions near the lunar poles, this hydrogen can combine with oxygen to form traces of water ice, preserved in areas where sunlight never reaches. Sunlight also plays a major role in shaping temperature across the moon. With no atmosphere to distribute heat, sunlight warms only the areas it touches. As the moon rotates slowly, regions move gradually from intense illumination into deep shadow, creating sharp contrasts between hot and cold that change at an unhurried pace. These temperature shifts contribute to the moon's quiet internal stresses. As rocks warm and cool, they expand and contract slightly. Over very long spans of time, this repeated motion can cause surface materials to crack and break apart, adding to the fine dust that covers much of the moon. Despite this constant exposure, the moon remains remarkably stable. Solar radiation does not erode mountains or reshape landscapes in dramatic ways. Instead, its influence is subtle, measured in chemical changes and microscopic adjustments, rather than visible motion. The relationship between the moon and the sun also helps define the lunar day and night. Because the moon rotates slowly, a single day on the moon lasts about 2 Earth weeks, followed by a night of equal length. This slow cycle creates long stretches of illumination and darkness, reinforcing the moon's sense of stillness and patience. For the human mind, this interaction between sun and moon offers a quiet contrast. The sun represents energy, motion, and outward force. The moon receives that energy calmly, reflecting light rather than producing it, changing slowly rather than dramatically. Together, they create balance. One drives activity, the other invites rest. As we continue drifting forward, this understanding will help us explore how humans have reached out to the moon directly, stepping briefly into this sunlight and shadow to learn more about a world shaped by patience rather than urgency. For most of history, The moon was something humans could only observe from a distance. It inspired stories, guided calendars, and shaped imagination. But it remained physically unreachable, separated from Earth by vast, silent space. That changed in the 20th century when curiosity and careful planning allowed humans to briefly cross that distance. Reaching the moon required more than speed or strength. It demanded precise timing, deep understanding of motion, and an ability to work with gravity rather than against it. Spacecraft had to leave Earth, fall toward the moon, and arrive at exactly the right moment when the moon's orbit carried it into position. The first successful journeys did not involve people at all. Robotic missions were sent ahead to test pathways, measure conditions, and prove that landing was possible. These early probes orbited, impacted, and eventually touched down, sending back information that transformed the moon from a distant object into a real place. When humans finally traveled there, they did so briefly and carefully. The lunar surface was unfamiliar and unforgiving, with low gravity, sharp dust, and long shadows cast by an unfiltered sun. Movement was slow and deliberate, shaped by bulky equipment and the need to conserve energy. Despite these challenges, astronauts collected rocks, set up experiments, and left instruments behind to continue measuring the moon long after they departed. Seismic sensors recorded moonquakes. Reflectors allowed scientists to measure the moon's distance from Earth with extraordinary precision using lasers sent from the ground. Each experiment added another quiet layer to our understanding. The time humans spent on the moon was short compared to the moon's long history. Footprints pressed into the dust remain exactly where they were left, unchanged by wind or rain. Tools and equipment still rest where they were placed, preserved by the same stillness that protects ancient craters. These visits did not change the moon itself in any meaningful way. They changed human perspective instead. For the first time, the moon was no longer just a symbol or a light in the sky. It became a tangible world, one that could be touched, measured, and slowly understood. From the moon's surface, Earth appears small and bright, hanging quietly in the darkness. This view offered a powerful reminder of connection rather than separation. Two worlds shaped together, continuing their shared motion through space. For the human mind, the story of reaching the moon is not about conquest or triumph. It is about curiosity carried carefully across distance. A brief meeting between a restless species and a patient companion that had been waiting, unchanged, for billions of years. As we drift onward, we'll begin to explore how the moon continues to influence human exploration today, not as a destination of urgency, but as a place of study, reflection, and quiet return. After the first human visits, the moon did not disappear from scientific attention. Instead, it entered a quieter phase of study, one defined less by dramatic landings and more by patient observation. The moon remained where it had always been, continuing its steady orbit, while human focus shifted and eventually returned with new questions. Modern interest in the moon is shaped by understanding rather than urgency. Scientists now see the moon as a valuable archive, preserving records of the early solar system that Earth itself can no longer offer. Its surface holds clues about ancient impacts, solar activity, and planetary formation, all stored in layers that have remained undisturbed for immense spans of time. Robotic missions have become central to this renewed exploration. Orbiters map the Moon in high resolution, measuring gravity, composition, and temperature across its surface. Landers and rovers explore specific regions, especially near the lunar poles, where permanently shadowed areas preserve cold conditions unlike anywhere else on the Moon. These shadowed regions have drawn particular attention because of their potential to hold water ice. In places where sunlight never reaches, temperatures remain low enough for ice to survive for billions of years. This ice is not visible from a distance, but its presence can be inferred through subtle signals and careful measurement. Water on the Moon carries both scientific and practical importance. It helps researchers understand how water moves through the inner solar system and how it may have reached Earth long ago. At the same time, it represents a potential resource for future exploration, offering the possibility of supporting long-term study without constant resupply from Earth. The Moon is also seen as a testing ground. Its proximity allows scientists and engineers to study how technology behaves in deep space conditions over extended periods. By working slowly and deliberately, lessons can be learned that apply to more distant journeys without rushing toward them. Throughout this renewed interest, the Moon itself remains unchanged in character. It does not respond differently to attention or neglect. It continues its motion, reflecting sunlight, shaping tides, and holding its quiet history in place. For the human mind, this return to the Moon reflects a shift in perspective. Exploration is no longer framed as a race, but as a conversation. Questions are asked carefully, and answers are gathered over time, rather than demanded all at once. The Moon offers patience in return. It allows observation without interruption. It holds its story still, waiting for those who approach with care rather than haste. As we continue drifting forward, this modern relationship with the Moon will help us reflect on why some places are worth returning to. Not because they have changed, but because we have. Beyond its physical influence and scientific value, the Moon has always held another role, one that is quieter and harder to measure. It acts as a mirror for human experience, reflecting not our light, but our attention. What we notice in the Moon often says as much about us as it does about the object itself. When nights feel long, the Moon can seem especially present. Its light spreads softly across familiar landscapes, making ordinary places appear slightly altered, calmer, and more reflective. This change is not dramatic, but it is noticeable, encouraging the mind to slow down and observe rather than act. Throughout history, the Moon has been used as a symbol for change, not because it changes quickly, but because it changes visibly. Its phases offer a reminder that transformation does not require force. It happens gradually, through repetition and return, shape by shape, night by night. Artists, poets, and storytellers have long turned to the Moon when trying to express feelings that are difficult to name. Loneliness, hope, continuity, distance. The Moon provided a shared reference, something constant enough to hold meaning without explanation. From a psychological perspective, this connection makes sense. The human mind responds to rhythm and pattern. Seeing the Moon's cycle repeat offers reassurance that change can be predictable and non-threatening. Even when circumstances shift, the moon returns to familiar forms, reminding us that not everything is uncertain. The moon also invites perspective. It is close enough to feel familiar, yet distant enough to remain unreachable in everyday life. This balance creates space for reflection, allowing thoughts to wander without needing resolution. In this way, the moon supports contemplation rather than decision. Modern life often divides time into rigid segments, marked by alarms, schedules, and expectations. The moon offers an alternative rhythm. It does not hurry. It does not signal urgency. It simply appears, follows its path, and leaves quietly when its light is no longer visible. For many people, noticing the moon becomes a grounding ritual, a pause during a walk, a glance upward before sleep, a moment of stillness that requires no response. These small interactions help settle the mind, reconnecting it with something larger and steadier than daily concerns. The moon does not solve problems or offer answers. It does something gentler. It creates space for thoughts to settle, emotions to soften, and attention to rest without direction. As we continue drifting forward, this reflective role of the moon will help us explore why it remains meaningful even in an age of constant information. Because some forms of understanding do not come from explanation, but from quiet presence shared across time and distance. Long before sleep was measured by schedules or screens, it was shaped by light and darkness. The moon played a quiet role in this rhythm, gently influencing how nights felt and how rest unfolded beneath the open sky. Even now, with artificial light surrounding us, traces of that ancient relationship remain. Moonlight is soft compared to sunlight, but it is still powerful enough to change the character of a night. On clear evenings, a full moon brightens landscapes, stretching shadows and revealing details that would otherwise fade into darkness. Before electric lighting, this extra illumination extended waking hours, allowing people to travel, gather, or work later than usual. These changes in routine likely shaped early beliefs about the moon and sleep. A brighter night meant later bedtimes. Later bedtimes meant shorter or lighter sleep. Over time, this pattern may have been interpreted as the moon directly affecting rest, when it was actually altering the environment surrounding it. Modern research has explored this connection carefully. Some studies suggest that around the full moon, people may fall asleep slightly later or experience subtle changes in sleep depth. These effects, when observed, are small and vary widely between individuals. They are influenced by light exposure, expectation, and routine more than by any direct physical force from the moon itself. The moon's gravitational pull on the human body is extremely weak. While it moves entire oceans, its effect on a single person is negligible compared to everyday forces. From a scientific standpoint, gravity alone does not explain changes in sleep or mood. What does matter is perception. The human mind is sensitive to changes in light, especially during the hours leading up to sleep. Even a gentle increase in brightness can signal alertness, delaying the body's natural transition into rest. In this way, moonlight acts indirectly, shaping sleep through awareness rather than force. There is also comfort in lunar rhythm. Knowing that the moon follows a predictable cycle can create a sense of order that supports relaxation. For some people, noticing the moon becomes part of a nightly ritual, a moment of recognition that helps the day release its hold. Sleep thrives on consistency. The moon offers consistency without demand. It does not interrupt or instruct. It simply marks time quietly, returning to familiar phases, whether we notice or not. In the modern world, where nights are often filled with artificial brightness and constant information, the moon can feel like a reminder of older rhythms. Its presence encourages gentler transitions into rest, not by changing the body, but by inviting attention to slow down. For the human mind, this connection between moon and sleep is less about cause and effect, and more about association. The moon signals night. Night signals rest. Over countless generations, this pairing became embedded in experience. As we drift onward, we'll begin to explore how this quiet relationship with the moon extends into dreams, imagination, and the subtle ways the night shapes inner experience, even when sleep finally arrives. When sleep deepens and the waking world begins to fade, the moon often lingers in the background of imagination. It does not enter dreams loudly or directly. Instead, it appears as atmosphere, shaping the tone of the night rather than the story itself. Across cultures, dreams have long been associated with the moon, not because the moon causes dreams, but because it accompanies the hours when dreams occur. As the sun withdraws and the world quiets, the moon becomes the most prominent presence in the sky, watching over the long stretch of night when the mind turns inward. In earlier times, moonlit nights were brighter and more visually active than moonless ones. Shadows moved, landscapes remained visible. The boundary between waking and dreaming could feel thinner, especially when sleep was light or interrupted. These conditions likely contributed to the belief that the moon influenced dream intensity or meaning. From a psychological perspective, dreams are shaped by memory, emotion, and recent experience. If the moon is part of the night's environment, it naturally becomes part of the imagery the mind draws from. Just as a sound outside a window can weave its way into a dream, so too can the presence of moonlight or a remembered image of the moon. The moon's changing phases may also influence how nights are perceived. A full moon can make sleep feel more alert, with lighter rest and easier awakenings. A darker night can encourage deeper sleep, with fewer visual cues pulling the mind toward wakefulness. These differences shape dream recall, not because dreams change, but because waking moments become more or less frequent. Dreams are remembered best when sleep is shallow or interrupted. On brighter nights, people may wake slightly more often, increasing the chance of remembering dreams. Over time, this pattern may have reinforced the idea that the moon created more vivid dreaming when it was simply making dreams easier to notice. Symbolically, the moon represents reflection rather than action. It reflects light. It reflects time. It reflects cycles. These qualities align naturally with dreaming, which often revisits emotions and thoughts rather than pushing forward into new decisions. For the human mind, dreams serve as a place where experiences are sorted gently, without urgency. The moon's presence mirrors this function. It does not interfere. It observes, It remains constant while inner landscapes shift and rearrange themselves. Even today, many people report noticing the moon before sleep and feeling it shape the mood of the night. Not through force or influence, but through familiarity, a quiet reminder that the world is still turning, even while consciousness drifts away. As we continue drifting forward, we'll begin to explore how the moon's quiet companionship extends beyond Earth, shaping how humans imagine space, distance, and their place within a much larger night sky. Long before the moon became an object of scientific measurement, it lived first in imagination. It hovered just beyond reach, close enough to feel familiar, yet distant enough to remain mysterious. This balance made it a natural place for stories, symbols, and meaning to gather. Across cultures, the moon has been imagined as many things at once: a guardian of the night, a marker of time, a witness to human lives unfolding below. Because it was always present, yet never altered by human action, it became a stable canvas onto which people projected thoughts, fears, and hopes. In ancient stories, the moon was often given personality. It was described as watchful, cyclical, sometimes gentle, sometimes distant. These traits reflected human experience more than lunar reality, but they helped people make sense of change, loss, and return. When something disappeared and came back again, the moon offered a visible example that endings were not always final. The moon's phases played a central role in this imaginative connection. Its visible transformation suggested renewal without destruction. Nothing was broken or replaced. The same object returned in a new form, over and over, reinforcing the idea that change could be safe and reversible. Even language absorbed this influence. Words connected to mood, cycles, and time often carry lunar roots. These associations shaped how people spoke about inner states, linking emotion to rhythm rather than permanence. As societies developed, the moon remained present in art and storytelling. Paintings framed it as a quiet companion. Poetry used it as a symbol of distance or longing. Music evoked it to suggest stillness or reflection. The moon required no explanation. Its meaning was understood intuitively. From a psychological perspective, this makes sense. The human mind seeks patterns that are steady but not static. The moon provides movement without unpredictability, offering reassurance while still allowing imagination to wander. It becomes a safe object for contemplation, one that does not demand attention or response. In modern times, the moon's imaginative role has not disappeared. Even with detailed knowledge of its surface and structure, people still pause to look at it, still notice its brightness, still feel something when it rises unexpectedly large on the horizon. This reaction is not about ignorance or superstition. It is about continuity. The moon links modern experience to something much older, reminding the mind that curiosity and wonder existed long before explanation. As we drift onward, this imaginative connection will help us understand why the moon continues to inspire exploration, not just outward into space, but inward into reflection, memory, and quiet awareness of time passing. The moon occupies a very specific place in relation to Earth. It is close enough to feel familiar, yet far enough to remain separate. This balance between nearness and distance has quietly shaped how humans understand space, not as emptiness, but as something that can still feel connected. At an average distance of about 384,000 kilometers, the Moon is Earth's nearest large companion. This distance allows it to appear prominent in the sky, large enough for the human mind to notice details like dark plains and subtle shading. At the same time, it remains far beyond everyday reach, existing outside the world of immediate action and responsibility. Light reflected from the Moon takes just over 1 second to reach Earth. In that brief span, sunlight travels from the Sun, touches the Moon's surface, and then continues on toward human eyes. This simple exchange connects 3 separate bodies through a quiet chain of motion, repeated countless times every night the Moon is visible. Despite this distance, the Moon does not feel remote in the way other celestial objects do. Planets appear as points of light. Stars remain fixed and unreachable. The Moon, by contrast, shows shape and movement. It rises and sets. It grows and fades. These changes make distance feel active rather than empty. From a scientific perspective, the Moon's distance is part of what makes its influence possible without being overwhelming. Close enough to shape tides, far enough to avoid instability. Its position represents a balance that has remained steady for billions of years, contributing to Earth's long-term consistency. For early observers, this distance carried meaning beyond measurement. The Moon was not just far away, it was a part. It existed in a space untouched by daily events, yet still visibly involved in the passage of time. This separation allowed the Moon to become a reference point, something steady against which change could be noticed. The human mind responds strongly to this kind of distance. Something too close demands attention. Something too far feels irrelevant. The Moon sits comfortably between these extremes, present without intrusion. This may explain why the Moon often brings a sense of calm rather than loneliness. It does not disappear into darkness forever, nor does it press itself into awareness. It remains available, returning regularly without requiring acknowledgement. In modern life, where distance is often collapsed by constant connection, the Moon offers a different experience. It cannot be reached instantly. It does not respond. It remains outside communication and expectation. This separation creates space for perspective rather than urgency. For the human mind, that perspective is grounding. Looking at the Moon reminds us that not everything needs to be immediate to be meaningful. Some things gain value precisely because they exist at a distance, steady and unchanged, allowing attention to rest rather than react. As we continue drifting forward, this understanding of distance will help us explore how the Moon connects generations across time. Because while distance separates space, repetition unites experience, and the Moon has been returning to the same sky long enough for countless lives to share it without ever meeting. One of the Moon's quietest qualities is its continuity. It does not belong to any one era, culture, or moment in history. The same Moon that rises tonight has risen over every generation before us, unchanged in form, following the same path across the sky. For thousands of years, people have looked up at the Moon from vastly different circumstances. Some watched from open fields, some from ships at sea. others from cities still lit only by fire and lanterns. Despite these differences, the moon appeared the same, offering a shared point of reference across time. This continuity creates a subtle connection between generations. A person living centuries ago saw the same phases, the same full moon rising slowly over the horizon. They noticed the same patterns, marked time by the same cycle, and felt the same quiet presence overhead. In this way, the moon becomes a link between lives that never overlap. From a scientific perspective, this consistency is the result of a stable orbit maintained over billions of years. The moon's path around Earth has changed only gradually, drifting outward by tiny amounts too small to be noticed within a human lifetime. To any single observer, the moon appears eternal. For early societies, this reliability made the moon a trusted guide. It helped structure calendars, rituals, and expectations. Its phases offered reassurance that time was moving forward, even when daily life felt uncertain or repetitive. The human mind is naturally drawn to symbols that endure. When something remains steady across change, it becomes meaningful without effort. The moon does not need to announce its importance. Its persistence alone is enough. This may explain why the moon often feels personal, even though it is shared by everyone. Each person encounters it privately, yet knows others are seeing it too. The same moon hangs above countless nights, witnessed by people who will never meet, yet momentarily connected through observation. In moments of difficulty or transition, this shared continuity can be comforting. The moon reminds the mind that change has always existed and that steadiness can coexist with it. Generations have lived, rested, worried, and dreamed beneath the same light, and then passed on, leaving the moon exactly as it was. In modern times, despite technological progress and constant communication, this connection remains intact. Looking at the moon still requires no explanation, no translation, and no permission. It simply asks for attention, briefly, before continuing on its way. For the human mind, this offers perspective. Personal moments are fleeting. Generational experiences overlap only slightly. But some things remain constant enough to be shared across centuries without changing at all. As we continue drifting forward, this generational continuity will help us reflect on why the moon often feels reassuring during moments of uncertainty. Because it shows that even as lives come and go, some rhythms remain, quietly repeating, long enough for countless stories to pass beneath them. Progress often suggests movement forward towards something new. The moon offers a different idea. It does not move away from what it has been. It returns. Night after night, the moon follows a familiar path, rising, setting, and reappearing in forms that repeat with gentle consistency. Its cycle does not accumulate or rush. It completes itself, then begins again, unchanged by how many times it has already passed. This quality of return has shaped how humans understand reassurance. When something comes back reliably, it becomes grounding. The moon does not promise novelty. It promises presence. Across generations, people have used the moon as a point of return during uncertainty. When days felt unpredictable, the moon still rose. When seasons shifted or lives changed direction, the moon continued its cycle, offering a sense of familiarity that did not depend on circumstances. From a scientific perspective, this return is simply orbital motion governed by gravity. There is no intention or meaning built into the process. Yet for the human mind, repetition itself carries meaning. The mind finds comfort in patterns that complete themselves without interruption. The moon's phases reinforce this feeling. A crescent grows toward fullness. Fullness fades again. Nothing is lost. Nothing is forced to remain. Each stage passes naturally into the next, then circles back again. This rhythm encourages a different relationship with time. Instead of seeing moments as permanent successes or failures, the moon suggests that states are temporary by design. Fullness does not need to be held onto. Darkness does not need to be feared. Both belong to the same cycle. In a world that often emphasizes forward momentum, the moon reminds the mind that returning is not regression. Revisiting familiar ground can be stabilizing rather than limiting. The moon itself never seeks progress. It maintains balance instead. This sense of return is especially present at night, when the moon appears again after absence. Its reappearance does not require acknowledgement. It simply resumes its place in the sky, unchanged, as if it had never left. For the human mind, this offers quiet permission. Rest can be revisited. Calm can return. Nothing needs to be resolved before allowing stillness to come back again. As we continue drifting forward, this idea of return will help us move gently toward the closing moments of our journey. Because the moon does not conclude. It circles back, leaving space for the night to settle without finality or demand. There is a quality the moon carries that is difficult to describe directly, yet easy to feel. It is not silence, and it is not emptiness. It is stillness. The moon does not rush through the sky. Its movement is so gradual that it often appears motionless, even though it is constantly traveling along its path. This slow pace invites the human mind to adjust, to soften its sense of urgency, and settle into a quieter awareness of time passing. Stillness does not mean inactivity. The moon is always in motion, always interacting with gravity, light, and space. But none of these interactions demand attention. They unfold without interruption, without acceleration, without noise. For humans, stillness is often misunderstood as absence or lack. Yet the moon demonstrates a different version of it. Its stillness is full. It contains movement, history, and connection, all held gently in balance. At night, when much of the world becomes quieter, the moon's presence becomes more noticeable. It does not compete with the day's activity. Instead, it accompanies the slowing of thought, offering a visual anchor that remains steady as the rest of the environment softens. The human mind responds naturally to this kind of steadiness. When external motion decreases, internal motion often follows. Thoughts begin to loosen their grip. Attention drifts rather than focuses. This transition is subtle, guided not by instruction, but by atmosphere. The moon's stillness also reflects acceptance. It does not resist its phases. It does not hold on to brightness when darkness returns. Each state arrives, stays briefly, and passes on without conflict. For the human mind, this can feel reassuring. Moments of clarity do not need to be preserved. Moments of heaviness do not need to be fought. Both are temporary, both part of a larger rhythm. In modern life, stillness can feel rare or inaccessible. Schedules fill time. Screens demand attention. The moon exists outside all of this, unaffected by human pace or expectation. It offers stillness without requiring withdrawal or effort. Simply noticing the moon can become an act of rest, not because it changes anything, but because it does not ask for anything in return. It allows the mind to pause without purpose, to exist without needing to produce or decide. As we continue drifting toward the final moments of our journey, this sense of stillness will carry us forward, not as an ending, but as a space where nothing needs to happen, where the night can deepen gently and rest can arrive in its own quiet time. There are moments when looking at the moon gently rearranges perspective, not by offering answers, but by widening the frame of attention just enough for urgency to loosen its grip. The moon does not explain, it contextualizes. From Earth, the moon appears large and immediate, yet its true scale exists far beyond everyday reference. It has been orbiting our planet for billions of years, witnessing oceans form, continents drift, and countless generations live and pass beneath its light. Against that span of time, individual moments soften, finding their place within something much larger and steadier. Perspective does not arrive through comparison alone. It emerges through duration. The moon's age, its unchanged surface, and its slow motion all communicate a kind of patience that words rarely capture. It reminds the human mind that many processes unfold successfully, without urgency, force, or constant correction. When worries feel immediate, the moon offers distance without detachment. It does not remove emotion. It places it within a broader rhythm. Just as tides rise and fall without resisting their movement, thoughts can be allowed to pass without being solved or suppressed. The moon's presence encourages observation rather than reaction. You can notice it without needing to understand it fully. You can feel its steadiness without assigning meaning. This kind of attention is restful because it does not ask the mind to decide or respond. In earlier eras, people used the moon to orient themselves physically. Travelers followed its rise and set. Farmers planned by its cycle. Sailors trusted its predictability when landmarks disappeared. These practices required patience and trust, qualities that remain useful even when navigation no longer depends on the sky. Modern life often compresses perspective. Time feels short. Decisions feel immediate. Attention narrows. The moon offers an opposite experience, expanding awareness without demanding effort. It exists beyond schedules, notifications, and urgency. This quiet expansion can be calming. When attention widens, pressure naturally decreases. Problems do not vanish, but they lose their sharpness. They become part of a larger landscape rather than the entire view. For the human mind, this shift is subtle but meaningful. Perspective does not require insight or realization. It can arrive simply by looking upward and noticing something that has been moving steadily long before any current concern existed. The moon does not minimize experience. It places it gently alongside everything else. In doing so, it allows thoughts to rest where they are, without needing resolution before sleep arrives. As we drift onward, this quiet perspective will help guide us into the final moments of our journey. Because rest often begins not with answers, but with the gentle realization that nothing needs to be resolved right now. As the night deepens, the moon continues its motion without interruption. It does not signal when it is time to rest. It does not instruct or advise. It simply remains, allowing the night to unfold at its own pace. This quiet presence gives permission for things to slow down. Thoughts do not need to be organized. Feelings do not need to be named. The moon offers no requirement for clarity, only space. Throughout this journey, we've explored what the moon is, where it came from, and how it moves. We've traced its influence through oceans, timekeeping, imagination, and sleep. Now those details no longer need attention. They can settle into the background, like knowledge resting rather than working. The human mind does not rest by effort. It rests by release. The moon models this perfectly. It does not try to hold its brightness. It does not resist shadow. Each phase arrives, stays briefly, and passes on without tension. At night, this rhythm becomes easier to feel. The world grows quieter. Edges soften. The contrast between motion and stillness fades. In this environment, the moon feels less like an object and more like an atmosphere, shaping the mood of the sky rather than the details within it. If you notice your thoughts drifting, that is not a distraction. It is a sign that attention is loosening. The moon has no expectation that you stay focused on it. You can glance, forget, and return again without interruption. This is how rest begins. Not with control, but with permission. Not with silence, but with gentle consistency. The moon does not need to be watched. It does not need to be understood. It continues regardless, offering stability without demand. As this section draws to a close, there is nothing you need to carry forward. No facts to remember, no ideas to hold. The moon remains where it has always been, doing what it has always done. In the final moments ahead, we'll let everything resolve naturally, not with an ending, but with a return to quiet presence, where the night can complete itself without instruction or urgency. As everything slows, the moon continues on its path. It does not mark an ending. It does not announce a conclusion. It simply remains. Long after attention drifts, long after thoughts soften and slip away, the moon keeps moving through the same sky it has always known. It reflects light without holding it. It follows its orbit without deviation. It asks for nothing and changes nothing by force. The facts we explored along the way no longer need to be held in memory. They have already done their work. They offered context, steadiness, and perspective, then quietly stepped aside. Like moonlight itself, they were never meant to demand focus, only to accompany the night. The moon has watched countless nights pass like this. Nights of worry, nights of rest, nights that felt endless, and nights that ended too quickly. Through all of them, it remained unchanged, moving patiently through the same familiar cycle. There is comfort in knowing that nothing needs to resolve before sleep arrives. The moon does not wait for understanding. It does not require calm. It simply exists, allowing the night to unfold in whatever way it needs to. If your thoughts are slowing now, that is enough. If they are still drifting, that is fine too. The moon does not measure readiness. It keeps time without judgment. Somewhere above, the moon is rising, setting, or passing silently through shadow. It is doing this whether it is noticed or not, whether eyes are open or closed, whether sleep comes quickly or slowly, and that constancy is the final thing to rest with. Not an idea, not a conclusion, just the quiet certainty that something steady remains, moving gently through the darkness, exactly as it always has. The night can finish itself now.